In this video, let us see about zero crossing detector. Zero crossing detector circuit is an important application of opamp in a comparator mode. It can also be called as a sine wave to square wave converter. The circuit is pretty simple with a voltage source or the signal input connected to the non-inverting input of my opamp via resistor R1, and the inverting input of the opamp is connected to ground via R. The resistors R1 and R limit the current through the clamping diodes. The two diodes are used to protect the op-amp from damage due to increase in input voltages. These diodes are called clamp diodes as they clamp the differential input to the op-amp at either 0.7 volts or minus 0.7 volts. There is no feedback in this circuit, so the op-amp will either switch to Vsat, positive Vsat or negative Vsat. We know that for a op-amp, in comparator mode, if V plus is greater than V minus, then the op-amp will go to positive saturation, and if V minus is greater than V plus, the op-amp will go to minus Vsat. Now let us assume there is a sine wave input given to my non-inverting terminal of the op-amp. For any positive voltage in this half cycle, diode D1 is forward biased, and we know the voltage across diode is 0.7 volts, and this 0.7 volts is the differential voltage applied to my op-amp. Because of the positive differential voltage, the op-amp will go into positive saturation, and in the negative half cycle, diode D2 is forward biased and the differential voltage of the op-amp is minus 0.7 volts, and hence the op-amp will go to negative saturation. This is how a zero crossing detector circuit works. Now, instead of 0 as reference voltage, I can have any value as my reference. For example, let us take 1 volt as a reference. Now, the switching takes place at the reference voltage, which is 1 volt. In this case, if V in is greater than V ref, the op-amp will switch into positive Vsat. And if V in is less than V ref, the op-amp will switch into negative saturation. In this circuit, the sine wave input is given to the inverting terminal of the op-amp and the non-inverting terminal is grounded, and clamping diodes are provided between the inverting and non-inverting terminals. The output waveforms are obtained on a DSO. As you can see from the waveforms, during the negative half cycle, the differential voltage is positive, and hence the op-amp switches to positive saturation. And during the positive half cycle, the differential voltage to the op-amp is minus 0.07, and hence the op-amp switches to negative saturation. The yellow waveform that you find here is the input to the inverting terminal of the op-amp, and the green waveform that you find is the output from the op-amp. The reason that the input waveform is clipped is because when the diode is forward biased, the input is being shorted to the ground, and hence you find that the waveform to be clipped.